Welcome, my friends. This is William N. Briggs, and we're up to episode 44 of Uncertainty and Probability Theory, the Logic of Science. And for the past few lectures, we've been discussing cause. And cause is everything. We're more or less interested in science, but of course, all of it, everything I've been teaching you applies to every single aspect of life, every single aspect of uncertainty or certainty, how we think. This is epistemology. And the reason that we focus on science is most people have an interest in science. So we get to call this applied epistemology or a mathematical epistemology, although the math so far has been light. We're about to come to it, though. We have 1 or 2 more weeks of cause left, and that's it. We're going to start right on the probability models. We'll return to Jaynes and continue on in uncertainty and so forth. But after we start on actual probability models, that's where normal classes start. So we're going to be up to almost lecture 50, not quite. By the time we get to probability models, ordinary, like a statistics or a probability course, will start right there. And they'll sort of wave aside and be vague about the philosophy behind all of these ideas. But of course, we don't do that. Our entire point is on the understanding of these models. Anybody, not for anybody, but for a lot of people, like myself anyway, mathematics comes pretty easy. And we can create these mathematical models that we haven't really done too many of them, but there's just books and books on them. We could create these mathematical models with ease, there's no problem. And we could go on and write lots of papers and prove theorems and all this kind of a thing and collect our lemmas and so forth. But we eventually have a time when we want to apply this stuff to the real world or for real questions that we have about the world. And in order to do that, we need a philosophy. There is no escaping it. And if you're going to be loose and vague about the philosophy, as almost all courses, normal courses on this thing are, you're going to be loose and vague about your conclusions. And if you follow my Substack or my blog, wmbriggs.com or wmbriggs.substack.com, there'll be links down below. And for years and years, we've gone through 1 paper a week on average, showing how bad things can go and how wrong things can go and how overcertainty just flourishes because of misunderstandings of the things that I have been teaching you and will continue to teach you. All right, this is episode 44. We want to know, we're still on cause. What causes cancer of the Albondigas? All right, so let's imagine we have a very typical scenario. We have over here a group of people, 1,000 people, and either no exposure to PM 2.5 or low exposure to PM 2.5. And we'll play back and forth with these two groups. But we'll start with thinking these people were not exposed to PM 2.5. PM 2.5 is a particulate matter of 2.5 microns or less. I think it's microns. It's dust. Dust in the air. But of course, we're in the age, and I just did yesterday and last week on the blog, on the Substack, showing you how everything can kill you. Science has proved, using the poor methods of statistics, that everything can kill you. And of course, everything can also cure you. Often the same things that they say will kill you with a particular disease will also cure that same disease. And you can prove it all using science. And I'm trying to show you how that's done. Anyway, so we have 1,000 people in this group. We're going to start thinking they have not been exposed to. Now, we did the whole thing on epidemiology about what exposed or getting a dose does. So you could go back and look at those lectures if you don't remember that. Right now, we'll just be content to be vague because that's the way we see these papers. Exposed to PM 2.5. None in this group. Turns out, of the 1,000 people we have, 995 of them, no cancer of the Albondigas. And 5 did develop cancer of the Albondigas. Okay? Now here's our second data point. This is the high PM 2.5 group, and we can let high be whatever happens to be in the literature, a definition of high. Doesn't matter. these people had sucked in some dust over a certain period of time or length, whatever. In this group, they're of the same size, 1,000 people. 985 did not get cancer, but 15 did. So I ask you, we want to write a paper about this. We're going to write a paper and say cancer of the Albondigas linked to, associated with PM 2.5. And the reason we're going to say that is because more people in this group were observed to have cancer than in this group. Now, let's think very carefully about this, as almost nobody does. And these, when they apply ordinary statistical methods. Now, I'm not going to show you today. I'm not going to do a hypothesis test as they normally do, or any kind of Bayesian model or anything like this. But if you were to plug this into a lot of the hypothesis tests that are used, a lot of the standard models, you'd find significance. And you'd have to declare, you'd have a null hypothesis of no cancer, and you'd reject that null hypothesis of no cancer, and you'd go out and declare that there is, in fact, cancer of the Albondigas caused by PM 2.5. And that's absolute BS. It's nonsense. You cannot claim causal effects using these probability models. And together, you and I are going to prove that to ourselves today. Okay. Well, if cancer of the if PM 2.5 is a cause of cancer of the Albondigas, how come only 15 people got it? We had 1,000 people who were exposed to it, but only 15 got it. If it is a cancer, and it is an operative cancer, it should have operated every time, unless there was something blocking it. These people were exposed. This is we're not saying, oh, maybe we mismeasured them and they really didn't have the exposure we say they do. No, that happens. That absolutely happens in science and so forth. But we're assuming, no, they did. They all actually did have the exposure as claimed, or dose. Anything you want to say. These people sucked in the dust. So how come everybody didn't get cancer? Is there an explanation for that? Well, obviously then, something else is going on. Otherwise, it can't be knowledge of PM 2.5 is telling us something about cancer, but it's not telling us everything. Otherwise, everybody in this group would have got it. So it can't be always a cause. But if PM 2.5 is a cause of cancer, it should always be a cause of cancer. Unless we're mistaken about the actual dosage or something like this. All right. Or we'll discuss that in a second. Or there's other ors that are involved in this. Now, here's the no PM 2.5 group. These people, 5 of them got cancer of the Albondigas. That cause absolutely could not have been PM 2.5. It had to be something else. All right? It absolutely had to be something else. It couldn't have been PM 2.5 because they didn't get any PM 2.5, and we're assuming that that's accurate. For this, it doesn't have to be accurate. Of course, there could be suspicions of measurement error, and we'll come to that kind of stuff sometime in the far distant future for those who are still sticking around with me. Well, then we know that there's at least some other cancer, other cause. We'll just call other cause. Oh, by the way, thanks to Paul for this chalk, this Korean chalk. This stuff is really quite fantastic. It's calcium carbonate chalk, and it's smooth. It just glides over the thing, and it doesn't leave scratches into the board and so forth. So it's very nice chalk. Thank you for that big box. That should last out at least for another few lectures. All right, so we have, what are the logical possibilities here? This is, all probability is a matter of logic. We proved that. We proved that from the beginning. There could be one cause. There could be one cause. There could be two causes. The two causes could be whatever this other cause is here. And we're assuming that this is a cause, but somehow not always a cause, which doesn't make any sense. Or there could be up to 20 or more causes. every single person might have got cancer of the Albondigas. Of the 20 people that we have, 5 plus 15, there could be 20 separate causes of cancer of the Albondigas. And whatever that happened to be, for each of these 20 people, they got it, and the other people did not. They did not have that cause. That cause was not operative in them. And it could be more than 20 because, logically, we only measured 20 people in this particular sample. There's more than 2,000 people in the world. There could be many more causes of cancer of the Albondigas than just these particular 20 that we measured. So, and there could be any number in between this. So, logically speaking, it could be also, I forgot to say, of course, logically speaking, there could be no cause of PM2. Well, there has to be a cause. I'm sorry. This is not a lot. This is I misspoke. We absolutely say there has to be a cause. These people actually got the cancer. We're assuming that's another assumption we make here, that the cancer was measured or diagnosed accurately. That can be wrong too. In real life, often diagnoses go wrong, much more often than doctors would like to say, but it happens. And there's gradations, of course, inside cancers. It's not just cancer, yes or no, or something like this, but that's what we're assuming for this particular data. Because this kind of paper is very common. We're not talking about stages of cancer or progression or all that kind of stuff. We're just saying yes or no. All right, so it has to be some kind of cause out there in the world, and that cause could be PM2.5, but if I say PM2.5 might adds nothing. If you remember, the probability that PM2.5 is a cause, given that it might be a cause, is any number between 0 and 1. It's contingent. Might adds no information. Might only says it's a logical possibility. You know, holding a piece of paper might be a cause of cancer. Holding Korean chalk might be a cause of cancer of the Albondigas. Being exposed to a LED light might only says the event is contingent. And every event that happens in the world, except for miracles, is contingent. Not necessarily true. The world was not set up so that these particular events had to happen necessarily, logically necessarily. So everything is contingent. Might adds no information whatsoever. So when we read these papers that say PM2.5 or in the news or something, PM2.5 might be a cause of cancer of the Albondigas, you've heard nothing. You're holding the newspaper or looking at the screen, the electromagnetic radiation coming off of your device might be a cause of cancer. You've conveyed no information whatsoever by using the word might. But they want to. They desperately want to, as we're going to see here. They desperately want to convey that information without the proof of it. Okay. All right. Yes, okay. So, all right, that's what we've learned so far. So, but there's some suspicion. There is some suspicion that something is going on here because this group only had 5. That doesn't seem to bother us too much because there could be any up to, in this case, at least 5 different causes. There could be just one cause, but it can't be PM2.5. We have absolutely ruled out, logically speaking, we ruled out PM2.5 as a cause in this condition. We have proved to ourselves, if PM2.5 is a cause, or if it isn't, we have ruled out that it is a cause in this small group, in this other group, this no PM2.5 group. That means we have at least one other cause existing in the world, and up to 5 or more. So now, how many of these 15, I'm asking you, how many of these 15 were caused, of these cancers that we observed here, were caused by this other cause? These could be other, this could be PM2.5, and this could be others still, that are completely different, that are not PM2.5. They could be this other cause that we've identified over here, or 5 of them. How many of the 15 were caused by this other cause? From the data that we have, how do we know? You tell me, how many of these 5 of these cancers, these 15 cancers, were caused by this other cause? 5, 4, 6, 15, all of them? You don't know. You can't tell. Logically, you can't tell. There's absolutely no way. It's, excuse me, my nose runs in the cold. And it's about 20-some degrees. I got it maybe just above freezing in here at the particular moment. The spring has not yet arrived in the reaches of northern Michigan. In fact, we got 4 inches of spring that fell on the driveway yesterday or the day before, and yesterday is just a dusting, I guess. Anyway, so we're trying to think. You and I are trying to think logically here. So we absolutely know for a 100% fact, it is an absolute true deduction that there is another cause besides PM2.5 out there in the world. And I'm asking you, how many of these 15 that we observed here, of these cancers of the Albondigas we observed over here, had that other cause that wasn't PM2.5? We don't know. We don't know. We do know that it's not wrong to suspect, you might think, that PM2.5 is a cause, because these people over here are more than the people over here. So it seems a little suspicious. But now let's think. Let's think about this very carefully. Excuse me. Let's think about this very carefully. Now let's go back. We only have 2,000 people here, and we're going to go back. And we did this on the blog on the was it yesterday? I guess it was yesterday. How does science prove that everything will kill you? And it's very simple. We go back in these people's lives and we start measuring. We compare people in these 2 groups. All right. So we compare, for instance, how many miles they live away from a city. Maybe these people all live within 10 miles, and these people all live within 1 mile. Maybe that's not right, because there'd be some people in here that live close to the city, and some people here don't. Okay, so what else? All right, we look back and we ask, how many peanuts have they eaten in their life? This is something that happened. How many peanuts? Maybe these people over here had eaten fewer or greater number of peanuts than the people over here. No, it turns out there's some overlap in the peanuts. Maybe there's a few people in here who had 800 handfuls, and there's some people over here who had 800 handfuls of peanuts. All right, so not peanuts. We keep looking, and we keep looking. So it turns out, suppose we do over here, and it turns out that everybody in this group, I wish I had, where's my other colors? This is good color. This here had +1, I hope this shows up on camera. Everybody in this group here, if you can see this, everybody in this group here, it turns out, had eaten in their lifetime, up to the point we measured their cancer, eaten at least 1 more banana than everybody in this group. Because the number of measures that we can take on people is nearly infinite. I mean, we could look at people every day over the course of their lifetimes, and over the course of every hour and every day and every minute and every day. We can compare every possible measurement that we could make. Not only will we have just one thing, we'll have lots and lots and lots of things that are different between these 2 groups, in which there's not going to be any overlap. Just as we're assuming now of no overlap, and we have whatever high PM2.5 means. You follow me? So we do know for a fact, we're assuming it's a fact. This is a local truth. Remember, we talked about the local and conditional truths, the difference between necessary truths and local truths. We're assuming it's a local truth that we've measured the PM2.5 accurately. We're assuming that. And that this is true. These people really did, we're assuming, have the high PM2.5. And we're assuming it really is true. These people had no exposure. All right? So then we look over their lives, over all the different things we could measure, and it turned, they would just absolutely, how many pieces of paper did they hold? How many times did they hold chalk in their hand? How many times did they record a video on a weekday? Everything that we could possibly measure on everybody over the course of their lives. And it's going to turn out this group will have no overlap differences with this group. And one of them might be just for the sake of supposing something, these people all had eaten one more banana than the people in this group. Now, so we can call this the low. It's the same data. The low banana group and the +1, or the high banana group, the high banana group. This is absolutely true. This is going to be the low banana group and the high banana group. Now, we have exactly the same data. Now we can write another paper. We can say bananas linked to cancer of the Albondigas. We absolutely can do this, and we can absolutely, we have exactly the same data, and if we're performing hypothesis tests, we can get the same p-value. I know I haven't explained any of that stuff yet, but we will. I would be able to proclaim significance. I'd have another paper to my name, and I can go back looking at that same data, and I can find other differences. Maybe on the amount of salsa they put on their tacos or something. Who knows? I could find endless numbers of things on this kind of a thing, and then I could compare these same groups. But that's absurd. None of that is telling me what's the real cause of the cancer of the Albondigas. Now, how do I do it? There is some suspicion. Why do we have some suspicion? Because we know something of the essence of dust, we say to ourselves. In other words, how do we know something about the essence of dust? We breathe in dust, it's bad for you. We start choking and coughing and so forth. And we have particular knowledge of how it might restrict blood flow as it leads to the Albondigas or something like this. In other words, we have absolute causal knowledge. We try to go in and find the causal mechanisms, the form, the material, the efficient cause, the final cause, the thing that ties it all together. We try to absolutely find a path, like we talked about last week, a causal path from the dosage of this particular thing to the presence of the cancer or not. And we might suspect we had that kind of a stuff. We had that kind of a thing with PM2.5 and cancer of the Albondigas. If we don't have that, we're just flagging around out there, and we could tell ourselves just so stories all the time about those. Oh, it might be this and it might be that. Well, then we have all kinds of other things like the low and the high banana group. We could fill this stuff in endlessly, and people do. There's just an endless stream of papers funded by you. Funded by the government to do this kind of crap, to look around and produce these junk papers like this. And there's thousands upon thousands upon thousands of these things, and they're more churned out every year because they don't think about these kind of things. Now, let's suppose that PM2.5, we're not done with this, all right? So you get the idea that we have to, this can, just like epidemiology, like I told you before, we have some suspicion here, you might say, but it's not enough. It's not even close to being enough. It's not even nearly close to being enough. You know, it's nothing. It's barely any evidence whatsoever. So we have to go on to search for actual causal mechanisms. All right? The things that bring about the cancer itself, that we can observe even, that we can control or test for, or something like this. We'll talk about testing and controlling and all that kind of stuff another time. But we have to do that dirty hard work, and it's brutal hard work, to actually demonstrate that something is a cause of a cancer like this. It's really hard. It takes years of effort and all this kind of a thing, especially when you can't necessarily do experiments because it's unethical. If you think if you really do think this particular substance is cancerous or carcinogenic, you know, you can only feed it to your enemies. You can't give it to the general populace and so forth. All right. So let's suppose we haven't reached some kind of a threshold, and we believe that that PM2.5 is some kind of a cancer, or it could be a cancer. We're still left with the fact that not everybody in this group got it, and that some of those causes could be this other cause, and probably are. What's to stop this other cause from working in this high group over here? You don't know. So it's not that 15 people are going to get cancer over here. The full they're all going to be PM2.5. They could be still other causes. So really what we're doing here, if we're saying PM2.5 is a cause, this is an assumption now. If we're saying PM2.5 is a cause, okay, then why doesn't everybody have it? Why doesn't all 1,000 people have? Why don't they all have the cancer? So now what we're looking for in that case is this is really now a model of blocking. Something is blocking or preventing the cancers in these other 985 people. What is it? Is it another cause that is countervailing the PM2.5 cause of cancer? These causes are battling it out. They have each one had that. Or are there different conditions, like particular genetic conditions? Conditions. This is our word. Conditions. Are there certain conditions that have to be in place for this particular substance to exercise its carcinogenic powers? All right? And these particular 985 people might not have had the conditions in place at the proper time or in the bodies or whatever. So this model is not so much a model of cancer. When we see these models out there, we're not modeling cancer at all. We're modeling the lack of conditions. If we think we can identify all of the proper conditions, then we would have identified the actual cause in just those 15 people. We could then spell out exactly what those causes and conditions are. And we don't have to write big papers that threaten and scare people about PM2.5. Now, these numbers, by the way, these are very, in fact, they're a little bit exaggerated. I think I'm on the high side by far, maybe by an order of magnitude, about the kind of papers that I've seen and so forth. And we'll talk about how they exaggerate even more. They'll say 3 times the risk. 3 times the risk of cancer. Well, it's because 5 times 15 is, or 5 times 3 is 15. And so, oh my God, we have 3 times the risk of being linked to cancer with PM2.5 exposure. None of that is true. Absolutely none of that is true. But that stuff happens all the time. So, again, we're looking for blocking because otherwise logically, something prevented these people from getting the cancer when we assume PM2.5 is a cause. We're assuming it is a cause in this case. We know it's a cause because we're accepting it. We can accept that all maybe these 15 people got it, but for some reason. But for some reasons, in other words, some cause, they didn't get it. Why? We have to explain that. This is the hard work that has to be done and almost, or far, far too often isn't done. By these people who flog these models and so forth. And just go back and look at my site, scroll back week after week after week. I do these kind of papers all the time. And I just did one, well, I guess it was today, lung irritation and climate change and so forth. It's crap. There's too much, I've said it many times, there's too many people doing this kind of nonsense. And this particular one I did today was NIH funded, 3 different grants, which means it's your money that's paying for this stuff. And it's slop. The government's handing out too much money. There's too many people in science. There's too many people doing science, and too much of it is bad like this. And a lot of the fault is just because mathematicians are so good at math, they want to come right to the fun stuff, the math, and they leave out all the philosophy. You've never heard a lecture like this when you're introduced to a test between differences in proportions, say, of something like this. You'll never get this kind of in-depth discussion in a normal class. That has to change. It won't change, of course. And I have to resort to doing this on YouTube because they won't let me in front of the kiddies since I was canceled. I'm a bad person. So it's up to you if you want things changed to change them yourself. You can't just you can't just go along the old system because the old system's not working. All right, that's it for this time. Next time we do more cause. We have to nail this cause stuff down before we get the probability models, but then we will. We'll get the probability models and we'll be very happy to start applying them. And then we're going to make all the mistakes that I told you not to make because you can't help yourself. You'll be beguiled by the way this stuff works in the software, and you'll just make every mistake there is, and it'll have to talk you out of it every single time you do it. that's it for now. More down below. Have lots of links. WMBriggs.com or WMBriggsSubstack.com. That's it for this time. Thanks very much for listening.